All right, so hello. Again, my name is Joey, and I'm going to be doing a lesson on, we're going to start this topic of Algebra 1. So we're looking at the US curriculum in this case. So again, just a little introduction for those of you who are just tuning in at home, or if you're kind of just on your devices, whether or not, again, my name is Joey. I'm currently a teacher candidate at York University in Toronto, and what I'm doing is I'm currently studying to become a secondary school teacher, and my teachables are chemistry and music. However, I'm planning to get my specialization in math as well. And if you're tuning in now, thanks for tuning in. I know with all the school closures and with amidst everything that's happening, I know it's sometimes hard to keep up with lesson to material. And although depending on if you're expecting or not, it might be hard for you to keep up. So again, OneClass is offering kind of these free lessons or free, so you can kind of tune in whatever you want. We have those videos saved for you as well. And what you can do is you can walk over and you can come and journey with me as well as we go through. This is Algebra 1. So that's kind of a little bit about myself. So thanks for tuning in if you're joining us from home. But what we're going to do is we're going to start our kind of lesson for today, and we're going to start this course on Algebra 1. So we're going to go back to the basics here. So what do I have on the screen here is I have algebra one here, and it's broken down to specific units here. So I have the kind of the basics. So again, we have like what a what a variable is, adding, subtracting, distributed properties. So we have equations here, inequalities, linear equations and inequalities. So we're looking at kind of like standard form of lines and slope intercept form and y-intercepts. We have trigonometry here, exponent rules and exponents, and then we have equations and inequalities, and then polynomials, and then we go to quadratics, radical expressions, rational expressions, and then some word problems and statistics. So that's how we're kind of break down this unit as well. Again, this is of US curriculum for Algebra 1. If you're tuning in and you're Canadian, this is kind of equivalent to kind of the grade 9 math curriculum. So this would be MPM 1D for all the Canadians or all the Ontarians, I'd like to say. But this is kind of what we're doing for kind of Algebra 1. So let's just get started. We're just going to start with the basics here, and we'll see, and we'll kind of breeze through this as well. For some of you, this might be a review. For some of you, this might be new material, so I'll try to kind of mix the two together, so provide you with the best kind of experience from at home. So we're just going to jump into this is writing variable expressions, and this is kind of what the worksheet that I have for you here. But what we're going to do is we're going to define some specific things first. So before we jump into the worksheet, let's just define specific things. So what is a variable? To write this down, what is a variable? A variable here just kind of represents what an unknown is, or what an unknown is. So a lot of times unknown, it could be a number, it could be an integer, it could be a decimal, it could basically be many things, but we don't know what a variable is. So, and what a lot of times when we just, this concept of solving for x, this concept of solving for variables is a very common concept. So, for example, we in math, we like to denote variables as kind of with letter names. So with letter names. And then, for example, e.g. here, like we usually use cursive as well. So x here, or maybe y, or z or z as well. So again, these letter names are in mathematics terms. It's some type of unknown. It could be a unknown number. It could be a relationship between a variable and a non-variable. So it doesn't have to be a number here. So number, it could be a number, could be another variable. It basically is something that's unknown, and we denote that with the letter x, the letter y, z, and basically any type of letter we can count that as a variable. So just a little review. We're just gonna go over and this is the concept of a variable. And what we're gonna do is we're gonna actually walk through this pretty quickly. This is for a lot of this is a review, so I'll try to breeze through this fast for this kind of fast part here. But what we have here is it's saying write each as an algebraic expression. So let's define an algebraic expression first. Algebraic expression. So algebraic expression, basically what that means in common terms, you're writing some type of mathematical. It could be an equation where it equals something, but expression just means it could be a combination of, it could be, oh, you can't see that, sorry. Combination of of numbers or variables, or honestly, a mixture of two, or a mixture of two. These are all algebraic expressions, a mixture of two. And what it usually has, an algebraic expression usually has some type of expression towards it. So it has some type of, like, it could be addition, subtraction. So you can add, subtract, multiply, divide, and these are all like very these are like expressions that you already know what to do. It could be exponents as well. It could be a lot of things. So you already know this. This is from your probably elementary school math. So this is just a review again. So again, algebraic expressions, what we can do is we can actually write them out in terms of numbers or in terms of variables. So we're moving from a word equation or a word expression. So this, I'm going to do some blue actually. So we're moving from this concept of words. So like a word, so words to kind of algebra, or to kind of a mathematical expression. So a lot of times just because we can't we can't see what we're trying to explain, sometimes it's easier to use like letters and numbers. It's kind of like speaking another language. So a lot of times, because we have a lot of expressions that are happening at the same time, it's easier to just visualize them with letters and numbers rather than to say, oh, the difference of 10 and 5, or you can just say, oh, it's just 10 minus 5, or like the quotient of 14 and 7, for example. Number 2 is just 14 divided by 7, right? So it's just basically, it's just another language that we're using to help communicate the same message. And that's what math is really. Math is really just it's just a different language. It's just a language that we should be familiar with ideally. So we have here, let's do number 1. Number 1 is really easy. We have the difference of 10 and 5, right? When we recall that difference, when we talk about difference, we're talking about this idea of subtraction, right? So very easy. So difference of 10 and 5 is simply just 10 minus 5, right? And we can solve this. In this case, we can actually solve this algebraic expression, and we can turn this into an equation. So 10 minus 5, we obviously know it's equals 5, right? So 10 minus 5 in this case, and I'll throw some terms at you real quick. So again, this part here is an algebraic expression. And this entire thing here, you can think of it as an equation, because it equals something. My subtraction, in this case, my difference of two numbers equals something. Most of the times, algebraic expressions could equal something. It could be equations, but a lot of times they're not. And we'll do some examples of that as well. So that's number 1. Number 1's really, really easy, right? And we can actually breeze through this because we can go pretty relatively quickly. Number 2, quotient of 14 and 7. Recall that quotient is simply just the answer when you're dividing two things, right? So this is the concept of division. So you can write this as it's 14 divided by 7, or I like to write it as a fraction. Now, some of you don't like fractions, like Joey. I hate fractions, but again, we need to be comfortable with fractions at this point. But you could choose to write it both ways. I personally prefer this right way here. This way here, I'm going to box this for you as well. And in this case, again, we can solve for this, right? 14 divided by 7, we know it's 2, right? So it's something we can solve. Again, this is an algebraic expression, but it can also be equation once I add this equals 2 here. So again, let's go and let's do number 3, because number 3 introduces the concept of variables. This is u decreased by 7. So when we're decreasing something, again, decreasing is just another word for subtraction, right? So decreasing, if we're increasing something, we're adding something, we're increasing the amount. For example, I'm increasing the amount of water in this container, I'm adding water. If I'm decreasing the amount of water in this container, I'm pouring out water, or I'm losing water, right? So I'm subtracting. So decrease, in this case, would equal subtraction, right? It just means subtraction. And again, we're just formulating mathematical sense of these words right now. And that's kind of the idea of Algebra 1 here. And we have u decreased by 7. We don't know what u is. U here is defined as a variable. So this is our first variable here is u. And we're going to decrease it, so subtract it by 17. And that's kind of our algebraic expression. In this case, we can't solve for this. This doesn't solve for anything. We don't know what u is in this case. We didn't define u as anything. So in this case, it was just an algebraic expression. It's not an equation. If we were to write equals 0, then we can solve for this equation, and we're going to do that in a later video as well when we're talking about solving equations. But this is a general algebraic expression for u minus 17. Again, it's u being decreased by 17. Again, I'm just going to do defining here. So again, u here is this concept of a variable, and it's our unknown in this case. And the 17 here is just a constant, or in this case specifically, it's an integer but you don't have. It's just a number, right? 17. We know that's a number. Let's move down to 8. Actually, 8's a bit more interesting here. So 8 says 6 squared. So when we talk about squared, it's talking about this idea of exponents. So squared, it's squared means, in this case, means to the power of 2. You can't see that, to the power of 2. And in this case, what that is, it's simply just an exponent. So I don't know if you're familiar with exponents, and maybe you have in a like your previous math course. But what that is you take 6 here, and you're going to raise it to the power of 2. So it's just a little 2 on this top right hand corner, and I'm going to define things as well. 2 here is the exponent. And 6 here, in this case, it's called the base. So we have the base, which is what that is, which is what the number being raised to the power of, and the 2 is just 2 squared. This also equals, exponents are an easy way to rewrite this here equals 6 times 6. So it's just the number, the base multiplied itself, and how many times it multiplied itself is the exponent. So again, in this case, if we have 2 6's, so that's my exponent is 2, and obviously the base is 6. And we can solve for this. 6 times 6, we know it's 36, right? So again, this is our equation now. And we're changing these from algebraic expressions, and some of them can also be defined as equations here. So that's 6 squared. Let's do 12 as well. 12 also has an exponent here. So let's do 12. Just making sure I have space for you all, sorry. So this is n cubed. Now, usually, so again, n cubed, and again, cubed here, we have n cubed, and we're doing number 12 here. N cubed is this, again, this word cubed also refers to kind of an exponent. So squared is to the power of 2. You can think of it as like a, I'm going to do a little side here, but a square here, I'm going to draw a square. A square here has 4 sides. And if you think about it, it has a length and a width. So it has 2 dimensions. So it's in 2D. So I think of it as to the power of 2. If you think of it as if you think of a cube, however, I'm trying to draw my best to draw a cube. This might be really bad. Is that a cube? Kind of a cube in 3 dimensions. It has a length, it has a height, a length, and a width. So I know width. So this is in 3 dimensions, which means it's to the power of 3, and that's how I think of this when we're talking about exponents. So it's to the power of 3. Of 3. So what we're doing here is now we're taking this n here, which is my variable. Again, variables are usually represented by letters. So we have, in this case, we have n, and it's going to be cubed, so it's going to be to the power of 3. And we can actually rewrite this. And we can rewrite this as, instead of n to the power of 3, we can actually, we know by our exponent number laws, we can say that this is actually n times n times n, because it's just n cubed, right? N times 3, n times 3. Sorry, it's not n times 3, n times n times n. So it's multiplied by itself 3 times, and that's what that is. So n cubed. So it's, again, we're rewriting multiplication in terms of the exponent if we're multiplying by itself, and that's what we're doing here. All right. So now we can, now what we can do is we can actually do the opposite, right? We can change verbal expressions or word expressions into our, no, we can change algebraic expressions into our verbal expressions. Sorry, got that mixed up. So this is here. Let me rewrite this. So it's 13. And we have here, it's x over 2, right? So we have x over 2, or x divided by 2, right? So you can say that this, there's a lot of ways to say this actually in words. We can say it's here, x is divided by 2. We can also rewrite this. You can think of it as an imaginary 1 here, because it's 1 times x. So you can rewrite this as half times x. Or you can say it's x times half. Or you can write this as half of f. It's just half of x, right? So there's a lot of ways to write a verbal expression for our algebraic expressions, and these would all be equal. These are all equal to x divided by 2. It's 1 over. It's just x over 2, right? We have x times half. That's also right, and half of x is also correct as well. Again, what we can do is there's usually students would actually write divide because we can see a fraction, but if you think of it, dividing is just simply you're also multiplying, because I'm actually factoring this half out, but we'll get into factoring as well. But a lot of students would probably either write x divided by half or half of x. It's not usually x times half, but there's a lot of ways. Again, we can manipulate a lot of these things to make them say what we want. So again, most of these students will choose these too, but I'm just telling you, the concept here is just there's many ways of writing this of x over 2 here. Let's do 16 because there's a variable here. So it's 5n. So again, we have a variable here. We have a n here is our variable. And it's, in this case, if it's stuck together like this, it's going to imply multiplication. So this implies multiplication. So if I have two numbers stuck together, or a number and a variable, this is going to imply that it's multiplication. Because a lot of times, like, what if I did something like this? F5 times this variable x. And this is not the question. But you can see how it gets very confusing, right? Because this x looks awfully a lot like this is a cursive x, which represents a variable. This here is a variable, and this here is multiplication. So you can see how things can get kind of tricky, or when mathematicians work with numbers and kind of multiplication, it kind of gets kind of tricky. They both look very similar. So what we do is we actually just get rid of this x. We're lazy and we just write 5x, and they're just stuck together very evenly like this. Like we just rewrite this as 5x, and it's going to imply its multiplication. So having known that, we can rewrite this as simply 5 times n, or you can say 5 times a number or a known. In this case, I would personally write 5 times n, because n here is the variable. Let's do a couple more before we move on here. Let's do 17 here. 17. We have this is a q and then a little 2 above it. So in this case, again, q here is my variable. This is, again, it's just a letter that represents some type of unknown, right? So we know it's q. So our word, we know it's q here. And this 2 here, again, this 2 represents this little 2 raised to this little 2 that's at the top right corner. This represents this idea of an exponent, right? Oh, sorry. This idea of an exponent. So again, if it's an exponent, we can say that q here is raised to the power of 2, or you can simply just say q squared. Or I'm going to write q to the power of 2. Most of the time we just say q squared, just because a lot of times, like, this is kind of just shorthand for mathematicians to say, oh, it's q squared. We don't say q to the power of 2. We just say q squared. That's what mathematicians do, just to save us some air, Same with if this was a q to the power of 3, for example. I'm just doing a little side here. If this is q to the power of 3, we just call this q cubed. And that rhymes. Not q to the power of 3, just because it's again, we're saving some time here, because to the power of 2 and to the power of 3 are very, very common exponents that we use regularly, so we just have them as just a shorthand here. Okay, so let's do some evaluating, and then we're gonna move on. A lot of these concepts are review anyways, so I'm expecting a lot of times we already know this, so we're gonna try to move on as quickly as we can here. So again, evaluate each expression. So let's do like maybe 4 of these ones, and then we'll move on. So 25 says 5 squared. So again, we have to go from, this is a word expression or a verbal expression, and what we're going to do is we're going to change it to algebraic first before we can do some type of evaluation. So there's 3 steps to this, and I'll write this in blue. So we have a word expression, and then we have to transform it to an algebraic expression, and then we have to change it to, and then we have to do evaluation. So these are our kind of 3 steps when we do these types of problems. So let's do it. So 5 squared, well, how do we write that as our algebraic expression? Well, we know that it's 5 here, and squared, again, we just talked about the exponents, right? It's raising to the power of 2, so we can say this is 5 squared, and this here is our algebraic expression. However, we can also evaluate this, right? We know this actually gives us a number. 5 squared, also we can rewrite this as 5 times itself, right? And just times itself once, so it's 5 times 5, and we know 5 times 5 here is simply 25. So again, 25 here is the evaluation of our algebraic expression. So we went from our word expression, step 1. Step 2 is our algebraic expression. And then step 3 here is our evaluation. So what does that actually give us here? What number does it give us? So we know 5 squared equals 25. Let's do every other one here. Let's do 27. So we have some type of continuity. So this is 20 decreased by 17. 20 decreased by 17. And again, we're going to go from a word expression to an algebraic expression to a evaluations. 20 decreased by 7. Again, we're decreasing, right? Decreasing means I'm losing, I'm taking away, or I'm subtracting, right? So we can say this is 20 decrease, so subtract 17, and that here is my algebraic expression. And we actually can solve for this, right? We can solve 20 minus 17 here is 3. So this is our evaluation. So this is, again, step 1 is our word expression, step 2 our algebraic expression, and step 3 is our evaluation. So our answer in this case, our answer here is 3. And I'm going to put an equal sign here just to denote that. 20 minus 17 obviously equals 3. So let's do 29. So it says here twice 6. So when we say twice 6, it's just we're talking about this concept of multiplication, right? So what's twice of 6, or what's 2 times 6 is another way of saying it. So if we write that down, we can say it's 2 times 6. So I'm going to use the multiplication sign because we don't have a variable in this case, but we can also write this as, if you don't like the multiplication sign, we can also write this as 2 bracket, and then we can do it like that. We can put 6 in brackets, and that also implies that it is multiplication. So 2 times 6, obviously, again, these two are also, these two here are acceptable algebraic expressions. 2 times 6, they both make the same thing, and that obviously equals 12 here in this case. So let's do these 3 quickly, and then we will move on to order of operations. So 31 is 9 times 5. Again, times is another way of saying multiplication, so you can say it's 9 times 5 here. 9 times obviously is 45. And again, word expression, algebraic expression, evaluation as well. And our last one, we have 33, right? We have 7 squared. 7 squared. Again, so we can rewrite this as 7 squared, again, means to the power of 2, right? So again, to the power of 2, so it's just a little 2 on the top right corner. And 7 squared is simply just 7 times 7. We can rewrite that in terms of multiplication, and that will equal 49. I'm actually not very familiar with the U.S. curriculum. I don't know. Do you get calculators? If you get calculators, you can kind of do this as well on the GER calculator. But if you're in the chat right now and tuning in, you can tell me whether or not you get a calculator on the test, and you can actually just plug this in. You can just plug in 7 squared directly, and you're going to get 49. Or if your teacher expects you to, your school teacher obviously expects you to write 7 times 7 to get you full marks, that works as well. But either way, I'm kind of breaking it down for you so that we're showing a step-by-step solution for all of these problems. So that's gonna be it for variables and verbal expressions. So then we're gonna move on here. We're gonna move on here to order of operations. So this works here, order of operations. So I know that in the US, you do order of operations differently here in Canada. In Canada, we do something called BEDMAS. But I know in the U.S. curriculum, or Americans, what Americans usually do is something called Pemdas. So I'm going to write that down. And I'll do Pemdas for you just because we are working with the American curriculum here. So this is Pemdas. So it's just an acronym here. Pemdas, what it is, it's an acronym for the order of operations. And an operation, and let me define this first. An operation is something like adding, subtracting. So you're adding, subtracting, multiplying, dividing. Sorry, that was really messy. Dividing. You can do exponents as well, and other stuff as well. So these are all operations, sorry, that's plural. And what it is every time we have an algebraic expression, we have an order of operations to do specific things. So that's why we have this almighty PEMDAS here. And that's going to tell us what order of these operations we're going to do them in. So here's an example. And let me define PEMDAS first for you before we start these examples. So PEMDAS, what it is, it's an acronym for an order of operations. So how we do our operations in a specific order. So there's obviously an order when we do math, and this is the order we always follow. So I'll break this down for you. So P here means parenthesis. So everything in parenthesis here we do first. So I'm gonna break this down in red actually. So here, so parenthesis always has. That's how you spell parenthesis, right? Parenthesis always has priority. So P here, this is the order. So P here is 1, 2, 3, 4. 1, 2. This is 3, and this is 4. Because I'll show you why. I'll show you about these numbers first. So again, 1 here is parenthesis. We do parenthesis first, always in order of operations. The next priority we have here is E, which is exponents. So again, exponents like powers or like square roots, for example, you might be somewhat familiar with. We're going to do those next. So this is exponents. So parentheses is kind of like this thing, right? It's just like little brackets. Exponents, we have something that's like to the power of 2 or to the power of 3, etc. So something like that. I'm just gonna I'll write like a variable. So like maybe c squared, for example, it would be a exponent of c to the power of 5 or something. These are all exponents, right? And then we have next here, number 3 here is we have m and d. M and d represent multiplication and division. So multiplying and dividing. And what that is, again, is you're multiplying or dividing, right? These are operations that we're already familiar with. And then lastly, we have AS, as you might know, would be adding and subtracting. So again, plus or minus. And again, adding, subtracting, we do all of these ones This is important. We do all of these ones from left to right order. So multiplication, dividing, this is from L to R. So from left to right. Same with adding, subtracting is left to right. And we're gonna do a lot of examples with this because this is a very, very important example, important concept in Algebra 1. So let's work on this worksheet here for order of operations. So let's do it. So we have our first question here. Says 3, and then there's a bracket or a parenthesis, and 6 plus 7. And I'm gonna write Pemdas here, so it gives you some type of a reference here. So again, in Pemdas, what do we do first? We do always parenthesis always goes first, right? So we have 6 plus 7 here in parenthesis. We do that operation first. So whatever operation in the parenthesis we is present, we do those first. So 3. So we don't do 3 times 6 here. We do 6 plus 7 first. So 6 plus 7 is obviously 13. So I'm going to leave that there. And then remember, if I have two numbers beside each other, this is simply just multiplication, right? So it's 3 times 13, which will give me a 39. So that's going to be our answer for our first question. So again, we're doing parentheses first. So remember, I'm going to do this in red. So this is P first. P is first. And then afterwards we do multiplication. So we don't do 3 times 6 plus 7. That doesn't fly. We got to do the parentheses first. And as we do more examples and as we follow along, you're going to figure that this is actually a pretty easy concept. So let's do number 2. Number 2 here is 5. Actually, I don't think I have enough space for number 2 on your screen. So let me do this on the bottom here, number 2. It says here 5 times 3 times 2. So in this case, we're still following Pemdas rules. In this case, our only operation present here is multiplication. And we're going to do multiplication from left to right. So this is from multiplying. So this is the M. So I'm just going to write M for multiplying. And then we're going to L to R. So left to right. So how do we solve this? So we do this. We do left to right. So 5 times 3, obviously here is 15. And then times 15 times 2. 15 times 2 here is 30. And that's going to be our answer for question 2. So I'm going to start doing every other ones because I know some of you might be already comfortable with this. So I'm just going to do every other ones, and I'll probably try to speed this up just because we are already familiar with this concept, or some of you are already familiar if you're watching at home here. So let's do let's do 3 and then 5 and 7 and so on. So there's question 3. We have 72 divided by 9 plus 7. So again, in this case, we have two operations. We have division and we have addition. So according to Pemdas, what we're doing first, D is before A, so we're doing division first. So again, 72 divided by 9 here is 8. And then we still have our plus 7. 8 plus 7 obviously is 15. And that's going to be our answer for number 3. Again, if you do have a calculator, your calculator already does all operations for you. So but what we're doing here is we're reinforcing it, because sometimes on a test, if you're not given a specific calculator, then you might have to do this manually. So just preparing you for that possibility. Number 5, I have here, it's again 9 plus 8 minus 7. So again, this is addition and subtraction. So in terms of Pemdas, some of you, this is where it gets confusing. So in Pemdas, sorry, I'm going to rewrite this. Rewrite Pemdas here. So in Pemdas, some of you might say, oh, addition is before subtraction, right? So we do addition first, right? Technically, no. Because addition and subtraction are the same they're at the same level of operations. So we actually do addition and subtraction left to right. And that's what we do, from left to right. So we don't do addition first. However, in this example, we do addition first. But we do it from left to right. So it doesn't really matter what we're doing first per se in this case, but we have to do addition subtraction because they're on the same level. It's going from left to right. So in this case, we do 9 plus 8 first, which is 17, minus 7. 17 minus 7 here equals 10. So that's going to be our answer for that. Let's jump down to 9. 9 looks kind of complicated. So let's do that. Go through the slightly harder ones. Yeah, the other ones have more operations. So let's do 9 here. So 9 here has, I'm get 20 divided by bracket 4 minus another bracket 10 minus 8 bracket. So, wow. So I have this equation is a bit more, or sorry, this algebraic expression is a bit more tricky, right? We have 20 divided by this mumbo jumbo here, 4 minus bracket 10 minus 8, right? So again, we're doing this concept of Pemdas. Again, parenthesis always goes first. So this division we don't worry about till later. Let's concentrate on this chunk here first. Specifically, what we're going to do is we're working from the inside to the outside. You can think of it as like a peeling orange or something like that. You work from, we want to get into like the juiciest part of an orange is on the inside, right? So we're going to do the inside first, and that's kind of how I visualize it. So this is 20. So we're just going to write 20 divided by, this is 4 minus, and we're going to do this bracket first. So we're going to do this operation first, 10 minus 8, because this is the most inside bracket. So we work from inside to the outside in the brackets. So 10 minus 8 here would just simply equal 2, right? So now our equation's a lot more simpler now. So we do 10 minus 8 first, because those are the inside brackets, and then we have to do the outside brackets, right? So this is 4 minus 2, which is simply just 2, right? So I'm going to rewrite this. This is 20 divided by 4 minus 2 here is just simply 2. And then 20 divided by 2 here is 10. And that will be our answer for number 9. So I encourage you to do a bit more practice. Let's do a bit more complicated one with a fraction. And then we're going to move on to the next topic here. So this is number 19. Or let's do 17 to 19. 17 here is, we have 43 minus 1 over 4 plus 2 plus 10. So at first this might seem kind of daunting, right? Like what do I do first? Like how do I approach this problem? So what we do have to do first, again, this fraction here means divide, right? So I want to do, according to Pemdas, I want to do division first. What other operations do I see? I see subtraction at the top, I see addition here, and I see addition here. But we also have division here, so we have to do division first. Therefore, we have to solve for these two parts. You can think of this here as one part, and this here as a second part. We have to do these two parts first before we do this plus 10 here. We're working from left to right. So 43 minus 1 here is 42. Divided by, what's 4 plus 2? 4 plus 2 here is 6. Right, and then we have our plus 10. So now it's a lot simpler, right? 42 divided by 6, we're doing division first in Pemdas. Remember, the D comes before the A here. So division before addition, and we're working from left to right. 42 divided by 6 here is 7 plus 10. 7 plus 10, obviously, is 17, and that will be our answer for 17. Let's do one more. Let's do 19. Oh, let's do 20. Let's do 20 here. I'm kind of going all over the place. I'm trying to pick questions that incorporate more concepts so that you're more familiar with this at home as well. So if we have 45 divided by 8, and then we have bracket 5 minus 4 minus 3. So again, Pemdas states that we do parentheses first. So let's do that first. So this is going to equal 45 divided by 8. So again, 5 minus 4 here, we're doing the inside operation first. For the 5 minus 4 here is 1. So I'm left with this 1 here minus 3. And again, I have this concept of division first and multiplication. But again, I can't do 45 divided by 8 minus 3 here. I have to do something else. I have to do this 8 times 1 here first. So I'll do that operation first. So it's 45 before I divide. Divided by 8 times 1 here is just 8 minus 3. Minus 3. Again, 8 times 1 here is just simply 8, right? And then what we can do is we actually have to do the bottom part first, because ideally we want to divide both these numbers, right? Because that's our order of operations. Again, division comes before subtraction. So 45 divided by, but in this case we have to do subtraction first before we even do division. So 8 minus 3 here is simply 5. And then 45 divided by 5 here is just 9, right? So that's kind of our order of operations for this kind of topic. Let's see. Let's maybe do one more because I kind of like question 24 because there's a lot of dividing and multiplying going on. So this is our last one, I promise, for this one. So 49 divided by 7 plus times, 60 over 2 times 5. So again, what we're doing here first is how I like to approach these things is I'm going to do kind of, I have dividing and multiplying, right? So they're all in the same level of order of operations. So I would ideally work from left to right, right? So again, 49 divided by 7 here is simply 7 times, and then what I have here is 60 divided by 2 times 5. Now, I can't do 7 times 60 divided by 2 times 5. I can't work from left to right anymore, so I can't do anything with this left-hand side. But what I can do here is, I can't do anything with the 60, but I can simplify 2 times 5, right? We know 2 times 5 here is 10. So I can do 60 over 10, right? And now, we can't do anything with the 7 here, so we have to work from left to right way. So we have to do 60 divided by 10 first. So 60 divided by 10 here is simply just 6. And then 7 times 6 here is 42. And that's going to be our answer for 24. So that's kind of this topic of order operations. I'm just going to do a brief review of Pemdas and of the variables before we move on. So let's go back to variables first. So again, variables here are just unknown numbers. They have letter names, and we talked about this idea of an algebraic expression. We talked about word expressions and verbal expressions, and then when we're talking about evaluation, we're talking about this concept of going from a word expression first to an algebraic expression and then towards evaluation. So that's how we're evaluating these expressions. We talked a little bit about how to represent things. So again, addition is we're adding the sum of two things, for example, or three things. The difference or decreasing would be subtraction. Multiplication would be times something, or twice of something, or 3 times of something. Division is simply the quotient, or you're dividing things between parts, so that's division. And then you have like exponents where you have 5 squared. 5 is to the power of 2 is 5 squared. 5 to the power of 3 would be 5 cubed, for example. So these are all these are all operations that we're doing. And then we introduced you to the concept of Pemdas, right? So Pemdas again is parenthesis first, and then it's exponents, and then multiplying, dividing, and then adding and subtracting. So again, we're doing left to right for multiplying, dividing, and for adding and subtracting. And then we did a bunch of practice problems with the order of operations with Pemdas. So that is that's the first 2 topics. We still have a bit more time, so I'm going to go over and we're going to try to tackle adding positive and negative integers super quickly before today's lesson is over. So positive and this positive and negative numbers, you can say integers, because integers are just simply their whole numbers, right? So we have, again, numbers can be positive or negative, and this is the concept of numbers can be either positive or they can be negative. So example, 3, 6, 9, they're all positive numbers, right? Negative numbers would be the inverse, right? -3 or -5, -10. These are all negative numbers. And what we're doing is we're going to add negative numbers, and we are subtracting negative numbers, or we're adding both positive and negative numbers together. And sometimes what that does is it's going to change our operation. So let's do a sample problem first. If we had something like we have 3 plus 3, obviously we know this is 6, right? We're adding 2 positive numbers, we're going to get a positive number. What if I added -3 plus 3? So now we're adding a positive number and a negative number together. So this is actually different, because -3 here is, you can think of it, you can visualize this as a number line. So if this is 0, this is -3, and this is 3, right? So I'm starting from -3 and I'm adding 3. Where am I going to end up? If I add 3, I'm going to go 1, 2, and then to 0. 1, 2, and then to 0 here, right? So this is actually going to equal 0. You could also visualize negative 3 as 3 minus 3 here. So what I'm doing is I am changing the order of which these two exist, and I'll be more clear about that right now. So instead of writing 3 plus 3, I am moving this negative 3 over to this side. So it would be 3 minus 3, and that will just simply equal 0. So that's how you kind of visualize adding or subtracting negative numbers. But what if I did something like, sorry, I don't know if there's any subtraction I think subtraction might be a different topic, but we're going to stick with adding. We're going to add positive and negative numbers. Let's do this first. So let's do number 1. So this is negative 7 plus 9, right? So if you have negative 7 plus 9, you can think of minus 7 as 7 below 0, right? So we have negative 7, and what we're going to do is, instead of, it's not 7 plus 9, because 7 plus 9 equals 16. That's not our correct answer here. We have negative 7. So how I think about this is, how many, at negative 7, how do I reach 0? I'll have to add a 7 to it, right? I'm adding 7 to negative 7 to get 0, and what am I left with? So I'm left with actually 2. So how I rewrite this is I'm going to do 9, and I'm going to bring this negative 7 here. I'm going to bring this to the right-hand side. So I'm going to write 9 minus 7 in this case. 9 minus 7 here equals 2. And that's how I work with, if this was for positive and for negative numbers as well. So 9 minus 7 here is 2. But what if I'm adding 2 negative numbers? Let's do that. So if I had negative, for question 2, I have negative 8 plus negative 1. How would I do that? So the rule for adding negative numbers is you're simply just adding them like they were positive numbers. So 8, you can think of it as 8 plus 1 here equals 9, right? 8 plus 1. If I didn't have the negatives, for example, 8 plus 1 obviously equals 9. If I have negative 8 plus negative 1, I'm going to actually have negative 9. You can think of this as you're simply just adding them as if they were positive numbers, but you're adding a negative in front of your answer. So negative 8 plus negative 1 is simply just negative 9. So let's do a bit more practice problems with these as well. So let's do every other one again. So let's do 5. So again, 5 here we have negative 8 plus negative 5. And again, negative 8 plus negative 5 here we have 2 negative numbers, so we can treat them as positive. So 8 plus 5 here is simply just 13. All we're doing is we're going to add the negative sign in front of 13, in front of our answer to get negative 13. So again, 8 plus negative 8 plus negative 8 plus negative 5 will equal negative 13 in this case. And let's do number 7. So we have 49 plus minus 15. So another way of writing this negative or this operation here is taking it out of the bracket. So we can say 49 plus negative 15, or we can actually write this as simply 49 minus 15. That's going to give us the exact same answer. So 49 minus 15 here, 9 minus 5 here is 4, and then 4 minus 1 here is 3. So our answer would be 34. So whenever we're adding a negative number, you can think of it as just simply subtracting, is how I think of it. I think about it as well. That's 49 minus 15. Same thing with number 9 is very, very similar. So let's do number 8 actually. So this is negative 47 plus 30. So negative 7 plus 30 here. Again, I can move this negative 47. I can move this number to this side, right? To this right side to make it 30 minus 47. And that might be a bit easier for you to visualize. 30 minus 47. So if I have positive 30, subtract 47, I'm going to get a negative number. So 30 minus 47 equals negative 17. And how do I know that? I know that because I have to do, so I'm going to do a side here. 30 minus 30 is 0, right? Equals 0. And then what do I have left of 47? So 47 minus 30 equals 17, right? So that's how I got the 17 over here. And then I put a negative in front of it because it's negative 17, because it's below 0, right? And that's how I did that kind of operation there. So again, this just takes a lot of practice and to just getting used to. Sometimes, oh, we can work with fractions as well. So let's do that, and decimals. So let's do that as well. So let's do one that's that has a bit more operations, and then we'll move on to decimals and fractions, and we'll probably call it a day. So let's do 17, or let's do 19 here. So 19, we have, this is 2 plus 6 plus -7 plus 10. So again, we have to follow this rule of Pemdas, right? These are all rules that always apply to these numbers as well. So this is adding and subtracting. So we're going from left to right. So again, 2 plus 6 here is 8, obviously. 8 plus, and then we have -7 plus 10. So now we're adding 8 plus -7, or I can rewrite it simply as 8 minus 7 plus 10, right? So 8 minus 7 here would equal 1, obviously. And then 1 plus 10, I'm left with just this. 1 plus 10 here is 11. So that's going to be my answer for 19. So let's work with decimals now. Let's figure that out. So decimals here, this is question 21. We're doing -6.8 plus 1.9. So again, what we can do is we can use a calculator, or I can do this manually. What we can do is we are going to what you could do is you can actually use calculator and take out -6 plus 8 plus 1.9. Oh, sorry, this is -1.9, right? Yeah. Oh, I messed up. It's -1.9. So it's simply, again, when we're adding two negative numbers, we can simply just add them like they were positive and just put the negative in front, right? So I'm going to do this manually because maybe you're not going to be a calculator. I'm going to assume you're not. So this is 6.8. We're going to treat them as positive numbers. 6.8 plus 1.9. So that's going to equal 8 plus 9 here is 7. I carry the 1 over. 1 plus 6 here is 7. Plus 1 here is 8. So we have 8.7. And all we're going to do is we're going to add the negative in front of it. And that's going to be our answer. Remember, we're adding two negative numbers. What we can do is add them like they were positive, and then just simply throw the negative sign in front of those answers as well. Let's do one that's slightly more complicated with 3. So let's do 27. And then we'll do stuff with fractions. And then, yeah, that's going to be our lesson for today. Don't want to overwhelm my students here, or the viewers that are watching at home. So this is 27. We have -2.1 plus -1 plus -7.6. So what we have here is, again, I'm adding, these are all at negative numbers. So I can add them like they were positive numbers. So I can actually just simply 2.1 plus 1 plus 7.6. So this is easy now, right? 2.1 plus 1 is 3.1. Plus 7.6 here. 0.1 plus 6 plus 1 here is 7. 3 plus 7 here is 10. So we have 10, and this is going to be 10.7. Oh, sorry. 10.7. However, remember, we are working with negative numbers, so we have to put the negative in front. So this is -10.7 is our answer here. So let's do the fractions for these ones, and then they might be a bit more tricky. I know a lot of students hate fractions, me included, to be honest. But let's work with these ones first, and then we'll call it a day. So this is 29. We have 5 over 3 plus -7 over 5. So in this case, if we're not given a calculator, what we have to do, if we're adding fractions or negative numbers, doesn't matter. We need to do lowest common denominator first. So again, we have 3 and 5 here, lowest common denominator for review here. I'm right LCD here, little sign in blue. Here's 15, right? Because 3 times 5 here is 15. So we have to change our denominators in terms of 15. So we have here 15. So 3 times what gives me 15? 3 times 5 gives me 15, right? So I'm going to multiply this by 5, and the top by 5, and this by 3, and this by 3 to give me a lowest common denominator of 15. So 3 times 5 is 15, obviously. 5 times 5 here is 25. Plus, and then we have negative, and this is over 15 again. 5 times 3 here is 15. 7 times 3 here is 21. So now we can work with these fractions, right? They are the same denominator. So what we can do is, again, I'm simply what I can say is my answer is going to be over 15, obviously. But we can do 25 plus negative 21 at the top. Remember, it's just simply 25 minus 21, which is simply 4. So our answer here is 4 over 15. So with fractions, we have to, again, we're taking this concept of lowest common denominator and then we're applying them in the context of negative numbers. So let's do 1 or 2 more, and then we're gonna call it a day here. And I'll kind of do a review of what we did today. So let's do 30. 8 over 5 plus, this is negative 1 over 3, right? So again, what is my lowest common denominator? Yeah, so it's simply just 5 times 3, right? It's whatever my denominator is multiplied to in this case. So LCD here is 15. Kind of nice because it was 15 before. So it's kind of the same thing here. So if my denominator here is 15 plus, I'm going to negative here is 15 here. What I'm going to do to the denominator, I'm going to multiply by 3, which means I'm multiplying the top by 3. I'm multiplying this by 5, and I'm multiplying this by 5 as well. So 5 times 3 is obviously 15 like we have here. 8 times 3 here is 24. 24. And then we have negative 3 times 5 here is 15. 1 times 5 is obviously 5 here. So now we have two different, sorry, this is 32, right? This is question 32, my bad. No, this is question 30. Yeah, question 30, sorry. I thought I got confused with the 32 here. 24 here plus negative 5 here simply is just 24 minus 5, right? So 24 minus 5 here is just simply 19, and our denominator remains the same, right? So it's 19 over 15. So let's do one more question before we go today. This will be my last question, I promise. Last question. This will be, let's do number 32. So this is half plus, this is negative 5 over 3. Again, my lowest common denominator here is 6, right? 2 times 3 here is 6. So I'm multiplying this by 3. I'm multiplying this by 3. Multiplying 3 times 1 equals 6. 3 times 2 equals 6. I have to multiply both sides by 2. What am I going to get? I'm going to get 3, it's going to be all over, denominator is going to be all over 6. 2 times 3 is 6 here, obviously. 1 times 3 here is 3. Plus, keep the bracket here, negative. 3 times 2 here is 6. And then 5 times 2 here is 10. And then what I have to do is, again, 3 plus negative 10. I can also rewrite this as just simply 3 minus 10. What is 3 minus 10 over 6? Which is simply just 3 minus 10 here equals negative 7 over 6. And that's going to be our answer for that question. So just a little review of what we did today. Brief overview. We covered actually quite a bit today, which is awesome. So I'm going to scroll up. We covered, again, adding positive and negative numbers. So again, if we're adding two negative numbers, we can treat them as adding positive numbers and simply sticking the negative in front of it. We can, if we're adding a negative number with a positive number, I can actually rewrite this and I can move it to this right side here to make it simply a subtraction problem, and that works as well. And so those are our two concepts for adding positive and negative numbers. If I scroll back up even more, we did order of operations today. So again, this concept of Pemdas here, again, parenthesis, exponents, multiplying, division, adding and subtraction, and this is the order of operations. So we did some problems with that as well. And then obviously we did the first part of our video, we did work with variables and algebraic expressions and evaluating those expressions according to what and answering the problem basically. So those are the three topics we covered today. We covered quite a bit. I'm just going to go over this as well. So for the next lesson, what we're going to do is we're going to go over number sets. We're going to go over adding. We're going to go over some multiplying, dividing rational numbers, and then we'll move on in our basics unit as well. So as always, thank you for watching and have a great day.